Hi Bobcats. In this video we're going to take a look at the concept of bond enthalpy, and in the next video we're going to use it to give us an estimate of the delta H of a reaction. So first we're going to look at what a definition of bond enthalpy, also frequently referred to as bond energy, is. So it just kind of depends on what textbook you're looking this up in as to whether it's bond enthalpy or bond energy. And a really important idea for you to walk away from this course with is that if a bond is going to form between two atoms, it's going to be exothermic, because if it's not releasing energy to put those two atoms in a lower energy situation, the bond will never form. And then we're also going to look at the connection between bond order, bond strength, and bond length. So bond strength will be quantified by the bond energy. The bigger the number associated with this bond enthalpy, this exothermic process, the stronger the bond is. And then the bond order is it a single bond, a double bond, or a triple bond? And then bond length is just the distance between the two atoms in the bond. So bond enthalpy is simply the energy or the enthalpy that's released when a bond is formed. Forming bonds is an exothermic process. Otherwise, bonds would never form. Breaking bonds, on the other hand, is an endothermic process. It requires energy be put into the system to break a chemical bond. You'll find tables like this one from your textbook that will show you bond enthalpy values for all kinds of different bonds. All of the bonds in this particular table are single bonds between a variety of elements. They're all listed as positive numbers, but do keep in mind that when this bond gets formed, that's the amount of energy that would be released. Or if you're going to break this bond, you've got to put in that much energy to break it. This table is showing you those bond energies for multiple bonds, and there's a pattern that I would like to point out to you, but we need a number off of the previous slide, which is the carbon-carbon single bond value, which is about 350 kilojoules. The carbon-carbon double bond value off of this table here on this slide is about 611 kilojoules, and the C triple bond C value from this table on this page is 835 kilojoules. So oh yeah, I didn't talk about what this asterisk means. The asterisk that's by all these numbers means that there is slight variation in this bond energy from compound to compound, depending on what else is near this particular bond in that compound. So those variations tend to be fairly minor, which is why we can assign a particular bond energy just kind of generically across all compounds. Now, what I wanted to point out here at the single bond versus the double bond versus the triple bond is if we only knew the single bond value of 350 and we were to predict the double bond, probably the simplest thing to do would be to say, okay, to go from the single bond to the double bond, you should multiply times 2. So that 350 times 2 would give us 700. But notice that that's double bond value is not quite 700. It's a bit short of that. It's 611. The second bond that forms, which is something that's called a pi bond that we'll learn about later, is not as strong as that first bond. And then if we were to compare the second bond to the third bond, so let's say, okay, we've got 611 for 2 bonds, so let's add another 350 to that to get our third bond. That would also be all the way up to 961. Or if we were to take the 350 and multiply it by 3, that'd be all the way up to 1050. So that third bond, again, is not as strong as the first bond, nor is it as strong as the second bond that gets formed. So each successive bond that we form adds to the overall bond energy. The triple bond has a bigger bond energy than the double bond. The double bond's a bigger bond energy than the single bond, but it's not just as simple as doubling or tripling the single bond energy. When we were looking at resonance structures, we're talking about bond order, bond strength, and bond length. And we said that the single bond is the weakest and the longest. The triple bond is the strongest and the shortest. And that will follow through here now that we have numbers to put for the bond strength. The single bond is the weakest of the three, and the triple bond is indeed the strongest. So our objectives were to define bond enthalpy. That's the energy that's released when a bond is formed. Forming bonds is an exothermic process, and we saw that the higher the bond order, the bigger the bond strength, and the shorter the bond length.